Good morning, dear student. Today I am going to discuss the next chapter, and that next chapter is what here? Semiconductor device. But in this semiconductor device, first thing, classification of material into conductors, insulator, and semiconductor on the basis of energy band diagram. So first thing, what is conductor, insulator and semiconductor? Are those material in which the charge carrier can flow easily or the charge can flow easily is called conductor, and in those materials in which the charge cannot flow easily is called insulator. And semiconductor are those material whose conductivity is less than conductor but more than insulator. Actually, in conductor and insulator, this can be also classified on the basis of number of free electrons. In conductors, number of free electrons is more. In insulator, number of free electrons is less. And in semiconductor are those materials in which the number of free electrons less than the conductor but more than the insulator. It means the conductivity of semiconductor is the intermediate of conductor and insulator. Now, what is energy band diagram? First question is, what is energy band diagram? Actually, in each atom possess their discrete energy level. हर एक एटम की अपनी discrete अलग अलग एनर्जी लेवल्स होती है. तो each atom is possess an individual atom. Each individual atom possess their discrete energy level. But in the case of any crystal, when these atoms comes very close to each other, then due to the interatomic forces, the energy level of these atoms is breaks into a large number of sub-energy levels. And these sub-energy levels are very close, means dense and continuous. So these dense and continuous sub-energy level is called energy band. And actually, in energy band, those bands are the highest energy band which possesses the valence electron. हाईएस्ट एनर्जी बैंड, ये भी एनर्जी बैंड बने हैं सब एनर्जी लेवल को टूटने के बाद, जो सबसे हाईएस्ट एनर्जी बैंड होगा. सो दिस हाईएस्ट एनर्जी बैंड which possesses the valence electron is called valence band. And above the valence band, the next possible band is what here? Valence band के ऊपर जो next possible band है, that one is called conduction band. तो ये हो गया valence band, और इसके ऊपर जो ये नेक्स्ट पॉसिबल बैंड है वो हो गया कंडक्शन बैंड. कंडक्शन बैंड इज एम्प्टी बैंड, ये खाली बैंड है. एंड दिस वन द वैलेंस बैंड इज द हाईएस्ट एनर्जी बैंड व्हिच पोजेस द वैलेंस इलेक्ट्रॉन्स. एंड द गैप बिटवीन दिस वैलेंस बैंड एंड कंडक्शन बैंड, दैट गैप इज कॉल्ड फॉरबिडन एनर्जी गैप. सो नाउ वी कैन क्लासिफाई between conductor, insulator and semiconductor on the basis of this energy band diagram. So first, how can we distinguish between them on the basis of this energy band diagram? So already I have told, valence band क्या है? Valence band is that highest energy band which possesses the valence electron. And next possible band above the valence band के ऊपर जो next possible band है, empty band, that band is called conduction band. And the gap between this valence band and conduction band is called forbidden energy gap. So first one, conductor. Actually, on the basis of this energy band diagram, I am going to classify between the conductor, insulator and semiconductor. So conductor means conductor are those material in which if the valence band and conduction band overlap. मतलब कि कंडक्टर वो है जिसमें वैलेंस बैंड और कंडक्शन बैंड दोनों ओवरलैप कर जाता है. एंड व्हेन बोथ आर ओवरलैप, देन फॉरबिडन एनर्जी गैप बिकम्स जीरो. ये के बीच में फॉरबिडन एनर्जी गैप या तो बहुत कम हो जाती है या तो ओवरलैप कर जाएंगे, तो ये फॉरबिडन एनर्जी गैप जीरो हो जाती है. इसका मतलब ये मान लीजिए हम पूरा का पूरा हो गया हमारे लिए कौन सा बैंड, ये हो गया वैलेंस बैंड, यहां से यहां तक ये पूरा हो गया वैलेंस बैंड। एंड दिस वन इज कॉल्ड, दिस वन इज कंडक्शन बैंड। तो ये पूरा हो गया वैलेंस बैंड और ये हो गया कंडक्शन बैंड। So this region is called what region here? Overlapped region. Overlapped region means the region which is common in both valence band as well as conduction band. ये दोनों में कॉमन है। इसका मतलब कि कंडक्टर के केस में वैलेंस बैंड एंड कंडक्शन बैंड बोथ आर ओवरलैप, फॉर्टन एनर्जी गैप बिकम्स जीरो। और जब फॉर्टन एनर्जी गैप जीरो हो जाएगी तो वैलेंस बैंड के जो इलेक्ट्रॉन हैं एट द रूम टेम्परेचर इजीली दे मूव फ्रॉम वैलेंस बैंड टू कंडक्शन बैंड। और जब ये फॉर्टन एनर्जी गैप बहुत कम या जीरो हो जाती है तो वैलेंस बैंड के इलेक्ट्रॉन रूम टेम्परेचर पे इजीली मूव कर जाते हैं वैलेंस बैंड से कंडक्शन बैंड में। और जितने ज्यादा इलेक्ट्रॉन वैलेंस बैंड से कंडक्शन बैंड में पहुंचेंगे उस सब्सटेंस की कंडक्टिविटी उतनी ही ज्यादा होगी। तो इन दिस वे यू कैन से इन कंडक्टर if the valence band conduction bands are overlap then that material is called what here conductor. Now next one is insulator. In insulator, if the valence band and conduction band have forbidden gap more than 3 electron volt, then the substance is what here insulator. It means in the case of insulator, suppose this one is valence band, this one is conduction band, and if the separation between valence band and conduction band, it means if the forbidden energy gap between these two bands is more than 3 electron volt, then that substance is considered as a insulator. So simply, in the case of conductor, valence band and conduction band are overlap. So gap between them, which is called forbidden energy gap, is zero. So easily electron moves from valence band to conduction band in conductor. But in insulator, valence band and conduction band, the separation between them, between this forbidden energy gap is more, and if it is more than 3 electron volt, then no any electron or very less number of electron will move from valence band to conduction band, और valence band से conduction band में जितने कम इलेक्ट्रॉन पहुंचेंगे उसकी कंडक्टिविटी उतनी ही कम होगी। और normally in the insulator at the room temperature, no any electron of the valence band are able to reach from valence band to conduction band, और जो valence band से conduction band में कोई इलेक्ट्रॉन नहीं पहुंचेंगे during this more energy gap, तो इसकी कंडक्टिविटी बहुत ही कम हो जाती है या जीरो हो जाती है। In the case of insulator, it becomes zero. So in this way we can define what here insulator. And third one is what here semiconductor. And now look here in semiconductor. Semiconductor. So in the if the valence band and conduction band have forbidden gap less than 3 electron volt, the substance is semiconductor. Here is semiconductor. It means in this case, if suppose the valence band and conduction band have forbidden gap less than 3 electron volt, then the substance is what is semiconductor. It means in this case here you can say this gap is less, and suppose this one is what here valence band, this one is conduction band, and forbidden energy gap is less than 3 electron volt, then this one is what here, this one is semiconductor. So in the case of the semiconductor, the gap between the valence band and conduction band is less than conductor. Is more than conductor but less than the insulator. सेमीकंडक्टर के केस में ये जो गैप है वो कंडक्टर से तो ज्यादा है लेकिन इंसुलेटर से कम है। So at room temperature also, the some electron of this valence band gain the sufficient energy and moves from valence band to conduction band. और इस तरह से वैलेंस बैंड के कुछ इलेक्ट्रॉन सफिशिएंट एनर्जी गेन कर लेते हैं रूम टेम्परेचर पे और कहां से वैलेंस बैंड से कंडक्शन बैंड में पहुंच जाते हैं। और जो भी इलेक्ट्रॉन जितने इलेक्ट्रॉन पहुंच जाते हैं तो उनकी कंडक्टिविटी क्या हो जाती है, बढ़ जाती है। इफ मोर नंबर ऑफ इलेक्ट्रॉन इज रीचिंग फ्रॉम वैलेंस बैंड टू कंडक्शन बैंड, more conductivity. No electron is reaching, less means zero conductivity. And if less number of electron is reaching, it means at the room temperature, the number of electron reaching from valence band to conduction band, in this case, is less than conductor. इसीलिए इसकी कंडक्टिविटी कंडक्टर से कम हो गई, बट मोर देन इंसुलेटर, और इंसुलेटर से ज्यादा हो गई। ये हो गई क्या, semiconductor का केस। तो simply you can say, in the case of conductor, valence band, conduction band overlap. In the case of insulator, this valence band and conduction band separated by a gap more than 3 electron volt. And in semiconductor, the gap between, means the Fermi energy gap between the valence band and conduction band is less than 3 electron volt. So in this way, we can define the conductor, insulator and semiconductor on the basis of the energy band diagram. Thank you. In the next video, I will do the next topic. Thank you.